In this video, we're going to talk about debugging. So logic errors are called bugs. The process of finding and correcting those errors is called debugging. So we can use a combination of methods to locate the part of a program where a bug is located. We can hand trace through the program and go through it line by line to catch our errors by reading the program. We could print out results as we're going through the program to try and trace it. And it would work fine for short programs, but the larger and more complex our programs get, the more need we have for a debugging utility. And that's what we're going to look at in this video. We're going to look at some of the tools that are built into NetBeans for debugging. And most of these tools exist in any IDE that you may be using. So a debugger is a program that facilitates debugging. We can use it to execute a single statement at a time. We can go through our program rather than click run and have it do 100 statements. We can make it go one statement at a time, and we can check the results after each statement. We can use it to trace into and out of methods. When we get to writing our own methods, we'll probably do a little bit more of that. We're going to learn to set breakpoints today. We're going to learn how to look at our variables. I don't know if we'll discuss call stacks yet, and we'll look at modifications of variables using the debugger that's built into NetBeans. All right, so I've pulled up a Java application we saw a few videos ago. This is the subtraction tutorial for, I think they said, a second grader. Two numbers subtracted. Let's talk about how we can trace through this program if we have a problem with it. Right now, I don't seem to have a problem because this is the way it's supposed to work when it runs. What is 9 minus 4? If the person puts 5, it says you are correct. Okay, what is 7 minus 2? If I put 6, it says 7 minus 2 should be 5. So we remember that program. Let's trace through it, and I'm going to put a bug in here. I'm going to change this minus to a plus. So now when I run it, it's 3 minus 0 is 3, and it says you're correct because 0. So this is a little bit tricky bug, because with 0 is here, it works correctly. 4 minus 3 is 1. Oh, it says wrong. 4 minus 3 should be 1, but I'd answered 1. So we have a logic error in our program. We have a bug, and we need to find out what the bug is. And we already know what it is. This is supposed to be a minus here. How do we find it, though, if we're not sure? Well, first thing that you need to know is that you need to know what to expect. That's probably the number one troubleshooting tool that I see. People will go through their debugger, but they aren't stopping to think about what to expect. So I'm going to show you how to go through one line at a time, and we do that by inserting a breakpoint. So I am going to put a breakpoint right here on line 10. Line 10 is where number 2 gets assigned a random number from the math class. So I'm going to go over here on the number 10, and I'm going to click it, and you can see I get a little red stop there. And that's a breakpoint. That means when I run my program with the debugger, it's going to stop at that point, and it's not going to go any further until I tell it to. So let's do that. Right next to my run button up here, I have a debug project button, and I need to push that if I want to debug the project instead of running it directly. So when I run it using the debugger, immediately this line turns green, and this green right here tells me this is the next line that will run. Okay, so it has not ran this line yet. It stopped before it ran that line, but it has ran the line up here. And if I go up and I hover my mouse over where it says number 1, I can actually see number 1 was assigned an integer 1. Okay, number 2, if I hover my mouse over number 2, it is not known yet, because we haven't actually ran this line of code. Okay. Also, I can look down here. There's a screen. Can I make that any bigger at the bottom? I can see number 1 is of integer type, and it is set to the value 1 when I look down here in the variables window. Okay, my output window is hidden back here, so if I want to look at it, I need to flip to it, because right now when I bring the debugger up, it's starting to show me what all the variables are in my project. So I see number 1 down here. Wish I could make that bigger. Hang on a second. Okay, I was trying to find a way to make my fonts bigger down here, but I can't. So let's go ahead and look up here. We have this set of buttons that wasn't there before we went into debugging mode. So we have a stop button that will cause our debugging to stop anytime we want to stop it. We have a play button that will cause it to resume anytime we want to. But the button I'm going to look at first is step over. So step over is basically a way of saying go to the next line, but don't go out of this class. Okay, we're not going to follow any function calls. So if I step over, it's going to run this line, which is line 10, and it's going to jump down to the next line. So let's do that. I'm going to step over, and you can see this line becomes highlighted in green, and this line has now ran. Down here we can see number 2 is set to an integer. It got 0 this time. So 1 and 0 are my 2 numbers. I can hover over them here as well. Number 1 is 1 and number 2 is 0. So if number 1 is less than number 2, is number 1 less than number 2? It is not. So this is false. So I would expect that I would not run the code in here and that I would jump down to this line next. So it's important to understand that. Okay, what do we expect to happen when we push this button? If something different than that happens, we know we have a problem. So it's always about what do we expect to happen compared to about what actually happens. So I'm going to hit step over. And again, I expected it to jump down. This line will be next. So we're good to go. Number 1, we can still look at our variables anytime we want down here. They're still set to 1 and 0. The next line is going to print out what is number 1 plus number 2, or number 1 minus number 2, I'm sorry. And that line ran. If we flip to our output window, we can see it, and it's waiting for our input. So scanner input is waiting for, we're getting ready to create a scanner, and then the next line, so let's do that. Now we have a scanner object, and when this line runs, it's going to get the next integer for us. So we need to put an integer in here, or what is 1 minus 0? I'm going to put 5. Okay, go back to my variables. There's no current thread running. Did I stop it by accident? I have to hit enter. All right, because I didn't enter my, so number 1 plus number 2 equals the answer. I should redo this one and get a correct answer. Let's do it again. I'm going to stop it. I'm going to run it with the debugger again. This time I'm going to fill out things correctly. Again, we don't know number 2. So 4 and 6. So this time this is true. 4 is less than 6, so we need to swap them. And so if we follow the code, step over, now we get down here. Temp is not known. Number 1 is known. So we can see temp is set to 4 now. Number 1, after we hit it again, number 1 is set to 6. And number 2 is now set to 4. So we've swapped the 6 and the 4. Notice they're bold down here. That means they've changed. System out. It's going to print. What is 6 minus 4? Okay, now it's waiting for my input. I'm going to put 2, which is the correct answer. And then this is where we inserted our problem, right? So we expect if number 1 plus number 2 equals our answer, but it's minus. Number 1, 6 plus 4 is supposed to be equal to 2, if we got it correct, but 6 plus 4 is not going to be equal to 2. So we would expect, if we did it properly, that it's going to say you are correct because we put in the correct answer. when I go to the next line, it doesn't go here because this wasn't true. And that tells us, since it didn't do what we expected, that tells us there was an error. There was an error back up in this line. And we would need to figure out what that error was. And then we'd say, oh, wait, we were supposed to subtract those two numbers, not add them together. Then we can stop. We can come and correct our code. And we can run it again. So that's what step over does. Let's run it again. Run with a debugger. Okay. I am going to this time pick this button, which is step into. Okay. And notice what happened. It took me into this double random code in math.java. And now it's wanting me to go in and troubleshoot the code that comes with Java. I don't want to troubleshoot the code that comes with Java. I'm pretty sure they shipped it out working. I didn't really want to follow that method. So when you do a step into, it follows any method calls that you do, even if it's in to a Java class that we had nothing to do with writing. So we know the problem is not there. So if you accidentally do a step into, there's also a button right next to it called step out that will return you back. It'll finish this and return you back to where you started. And that's what we did. I can shut this math.java. Okay. So it tried to go run this math.random and let us troubleshoot that code. That's why step over at this point in your life is probably what you want to be using to run one line at a time. And if at any time you want to, okay, I'm done troubleshooting, I can just hit continue and the program will finish running. What is 8 minus 4? It's 4. My program is working. All right. So that's the debugger. It lets us see values of things as our program's running, run one line at a time, compare what we expect to what's actually happening so that we can find out where the problem lies.